Next is common source amplifier with diode connected load. Here we have an NMOS. Input is given to the gate of NMOS. Source is connected to the ground. Output is taken at the drain, and the load is a PMOS diode. So for a PMOS diode, the gate and drains are shorted and the source is connected to VDD. So let us find the gain of this circuit by intuitive analysis, and then gain of the circuit by small signal model analysis, and finally let us see how will be the voltage swing of this circuit. First one is by intuitive analysis. The gain of any circuit is given by gain equals to minus GM times RO. Here GM will be equal to GM1, that is where the input voltage is supplied to, and R out is given by, this is R out which we will be looking at, is given by R out seen up parallel to R out seen down. R out seen up is nothing but 1 by GM2, and R out seen down is nothing but RDS1. So R out will be 1 by GM2 parallel to RDS1. So here we know that RDS1 is a large value in mega ohms and 1 by GM2 is a small value. So 1 by GM2 parallel with RDS1 will be equal to 1 by GM2. So the gain of the circuit is nothing but gain equals to minus GM1 times R out, that is 1 by GM2. If GM1 is equal to GM2, then gain will be minus 1. This works as a buffer, that is as a inverting buffer, and inverting voltage buffer whose R out is of a very low value, which is given by 1 by GM2. Let us find the gain of the circuit by using small signal model analysis. So write down the small signal model of the common source amplifier with the PMOS diode load. Here gate G1 is the gate of T1, source S1 is connected to ground, VGS1 is nothing but Vn, so current is given by GM1 times Vn. We have RDS1. Drain of T1 is connected to drain of T2, that is nothing but V out, and here the gate of T2 is connected to drain, hence it is shorted. Gate to source voltage is given by VGS2. Here VGS2 is nothing but VDS2. So the voltage controlled current source is replaced by a resistor given by 1 by GM2. Actually here it should be GM2 times VGS2. Since VGS2 is nothing but is equal to VDS2, we can write this as GM2 times VDS2. In this case, the voltage controlled current source can be replaced by a resistor given by 1 by GM2, and the voltage across it will be equal to VDS. So we have written a resistor given by 1 by GM2 and the voltage across it is nothing but VDS, and then we have an RDS2 of T2 connected between Vout to ground. So when since S2 and S1 are grounded, we can flip this circuit down, that is GM1 by GM2 comes in parallel to RDS1 and RDS2 will come in parallel to RDS1. So the equivalent circuit will be like this, where RDS1, RDS2 and 1 by GM2 are in parallel. We have GM1 times UN and we have G1 which equals to Vn. G2, D1 and D2 is nothing but Vout. Finding GM. To find GM, we need to make Vout equals to 0 and find what is Iout by Vn. So make Vout 0, that is short Vout to ground. When we short Vout to ground, the resistors gets shorted. We are left with GM1 times Vn. So Iout will be equal to GM1 times Vn. So Iout by Vn will be equal to GM1. So GM of this circuit equals to GM1. Finding Rout. Rout is equal to Vout by Iout given Vn equals to 0. So short Vn. So here the voltage control current source value will be 0. So you can open this circuit. So here Vout is nothing but Iout times RDS1 parallel RDS2 parallel 1 by GM2. We know that RDS1 parallel RDS2 parallel 1 by GM2 will be equal to 1 by GM2 because RDS1 and RDS2 are very high values when compared to 1 by GM2. So the gain of the circuit is given by minus GM times Rout, where GM is GM1 and Rout is 1 by GM2. Substituting this, we get gain equals to minus GM1 by GM2. So if GM1 is approximately equal to GM2, then the gain of this circuit is minus 1. This is an inverting buffer, voltage buffer, whose gain is given by minus 1 and its Rout is a small value which is given by 1 by GM2. Next is finding the gain using direct approach. Draw the small signal model of the circuit which is shown here and find the KCL at node D1. Here the current flowing in from Vout node will be equal to 0. So at this node you find the KCL, the current GM1 times Vin plus current flowing through RDS1, that is Vout by RDS1 plus current flowing through RDS2, that is Vout by RDS2 plus current flowing through 1 by GM2, that is Vout by 1 by GM2 will be equal to 0 as shown here. So GM1 times Un can be written as equal to minus Uout into 1 by RDS1 plus 1 by RDS2 plus 1 by GM2. So Uout by Un is nothing but minus GM1 divided by this term. So this is nothing but minus GM1 times RDS1 parallel RDS2 parallel 1 by GM2, just shown here. Since RDS1 and RDS2 are very large values compared to 1 by GM2, we can approximate this as minus GM1 times 1 by GM2. Next is the voltage swing. The input voltage swing. This circuit has a good input voltage swing as the PMOS diode self biases, we only and always remains in saturation. That's the property of a PMOS diode or an NMOS diode. We should make sure that the transistor T1 is in saturation. Coming to the output voltage swing, so the V out maximum cannot be equal to VDD because this transistor T2 has to be in saturation. So condition of saturation for PMOS diode or for any transistor is that VDS should be greater than VGS minus VTH. Since it's a PMOS, we can write it as magnitude of VDS2 should be greater than or equal to VGS magnitude of VGS2 minus VTH. But for a PMOS diode, the drain to source voltage is fixed, which is equals to VGS2. So VDS2 is equal to VGS2. So this voltage is a fixed voltage value. Hence, VDS2 is we can write this as VGS2 effective plus VTH. VGS2 effective is nothing but VGS2 minus VTH. So both VTH plus VTH minus VTH cancels to give VGS2. So the VDS value, max, min or average, whatever is, everything remains same, will be equal to VGS2 effective plus VTH. So the maximum value the V out can take is nothing but VDD minus the voltage drop across transistor T2, that is nothing but VGS2 effective plus VTH. So V out max equals to VDD minus VGS2 effective plus VTH. Minimum value that V out can take is not 0 because the transistor T1 has to be in saturation. So VDS should be greater than or equal to VGS minus VTH. This term. So VDS1 minimum will be equal to VGS1 effective.